So today we're going to be going over lesson 3, which is present value. There is homework questions for this. They're going to be posted to Google Classroom over here at page 439 to page 441. Numbers 1, 3, 6, 8, 10, and 11. I've gone in and highlighted them for you as well so that you can just see which ones you need to do, so you don't need to come back and refer to this particular lesson. But that's what it's going to be. So this lesson's really quick. It should probably be like a 10-minute video. It's just going to be, we're going to be going over present value and on how to find it and what's the purpose of finding the present value. So the present value is the amount of money that you need to invest now to produce a desired amount in the future, right? So how much do I need to put into this bank account now if this is how much money I want to have 10 years, 5 years, 6 years down the line? We use present value mostly for if I want to know how much I want to save in the future, if I want to know how much I need to invest into a stock to know how much I want for something else in the future. A lot of people use it as a way to invest and do RRSPs, which is your retirement saving plans, as well as your RESPs, right? So when you move forward, your parents might have done this, or your parents or guardians might have done this for you, or you might do it for your future children in the future, which is where you invest a set amount of money at a very, very young age. So usually when a child is born, you'll buy them an RESP, which is a registered education savings plan. So you put in a set amount of money, and that money, you just leave it in the bank account and it grows. You can figure out how much you need to invest now to have a desired amount in the future. And you can figure that out by using this present value income, or this present value statement. Right? So the first example is, suppose we want to have $4,000 available to us 3 years from now to go on a trip. At the rate of 4% per annum, and per annum just means annually, compounded at a quarterly basis, how much should we deposit now so that we have enough money 3 years from now? Right? So before we get started, let's go in and write our equation. This is a compounding interest, right? So we're going to write in A is equal to P 1 plus I to the power of n, right? That's the equation we're going to use. Now I'm going to go think to myself, okay, what is P? P is obviously we don't know, because that's what we're looking for. We want to know how much to put in now, right? Our A is going to be how much we want in the future, which is $4,000, right? Our interest, if we go back and look at our chart, it says that for something that's compounded quarterly, you're going to take the interest rate, right, and divide it by 4. So in this situation, our interest rate is 0.04 divided by 4, which is going to give us a total of 0.01. And in this situation is going to be number of years times 4. So that's going to be 3 times 4, which is going to be 12. Right? So that means that the number of compounding periods we have over 4 years, over 3 years, is going to be 12. Let's just go put in what we know, right? So we know A is 4,000. We don't know what P is, so we're going to leave that alone. 1 is just a constant. We know I is going to be 0.01. And we know n is going to be 12. Let's just solve what we can solve now. Leave the 4,000 alone. We can't really do much to it. P, we can't do much to it. We can add what's in the bracket, so it's going to become 1.01 to the power of 12, right? Now I can do that exponent as well, so I'm going to do P 1.01 to the power of 12 is just going to be 1.1268250, and I'm sure there's more numbers to this, right? Now I know that it's P times this big huge number. I can just divide both sides by this number to isolate for P, right? So let's try to get P by itself, because that's what I'm trying to find, right? So I'm going to do 4,000 divided by 1.1268250. 3, I think. I even added a 3 at the end of it in my actual original calculations. So I'm just going to do that. And if I put that all into my calculator, I'm going to get 3,549. So 3,549.80. And I like to leave the dollars always as 2 decimal places only is equal to my principal amount. That means that in order to have $4,000 3 years in the future, I need to put in $35,400 or $549.80 right now, right? So therefore, must invest 35,449.80 now. That's my answer. Another thing we can do is that notice that here we plugged everything in and we did it and then we divided at the end. What you can actually do is we can rearrange this formula, right? So let's just work with just the variables. So I know my formula is originally going to be A is equal to P1 plus I to the power of n. And if I wanted to find a formula for just principal, I would just need to rearrange the formula to solve for principal. So the first thing I can do is divide both sides, right? I'm going to do this in pink. Divide both sides and isolate for p, right? So let's get rid of this 1 plus I to the power of n. So I can divide this side by 1 plus I to the power of n. Whatever I do to one side, I have to do to the other. So I can do 1 plus I to the power of n. So in this situation, I can just cancel these out. So I'm left with A equals 1 plus I to the power of n is equal to P, right? And if I want to make this even easier for myself, I can use my exponent rules, right? So let's use my exponent rules. And the negative exponent rule particularly. Right? And work backwards. So we know when there's a negative exponent, we put it in the denominator, right? So if I want to go put it back in the numerator, I know that this exponent is to the positive end. If I want to make it uncomfortable, I can just change it so that it becomes A 1 plus I to the power of negative n, because that would just be divided by n, over equals P. And that is my equation for principal. And I can just use this equation from now on, right? Instead of having to always plug it into the formula that way. Sometimes it's helpful to use the other variables we learned about, not yesterday, the day before yesterday, and we can rewrite the same formula. So instead of having A, you can have FV. So I personally hate this way, but if it makes life easier for you, be my guest. I have no problem with that. So we can write this as present value, which is just our principal, is equal to future value, right? Times 1 plus I to the power of negative n. And it's almost identical to if I had written this as future value is equal to P 1 plus I to the power of n. It's just your n now is negative when you're trying to find the present value instead of positive when you're trying to find the future value, which makes sense. If you're going back in time, your n is just going to be negative. Right? That's how I like to remember it. Again, personally, hate rewriting this formula. For me, it just clicks better if I actually do the rearranging or if I write it this way. But if this works for you, it works for you. Be my guest, you can do it that way. Okay? It just might help you keep track of what you're actually calculating. That's all. Present value can also be used in paying off debt early. Right? This is called a discounted value of a loan. So creditors, which is a money or organization that lends you loans, and you can have different types of creditors. You can have your bank that is a creditor, right? You can take a loan from the bank, or you can take loans from different people. You might take them from a private company. You might take them from a private organization, because You might not have the credit score to get it from a more well-known organization, like a bank might not give you a loan, but an independent creditor might, right? They also might give you a lower interest rate than a bank would. So you can always do that. So some creditors might sell their loans to other creditors at a discounted value of the loan by calculating the present value. So sometimes if I borrowed, say, from an independent creditor, they might actually sell it to another independent creditor for a discounted rate so that that creditor ends up getting paid. They could be doing this for a multitude of reasons. They might need the money right away. There might be different reasons why someone chooses to do this. So we'll do an example here. So Amandeep has a loan for $10,000 that she loaned out to someone, right? Or she borrowed from someone. She wants to pay off her debt early. The creditor is willing to discount the loan at an interest of 9% per year, compounded semi-annually. How much would the creditor be willing to accept today, right? So let's go in. We're going to be looking for the present value, right? So the present value, we don't know what that is. We know that the future value, or how much she owes eventually, is going to be $10,000, right? We need to find the I and we need to find the N. So in this situation, right, it says semi-annually. So if I go back and I look at my sheet that I have from class, semi-annually means 2 times a year, right? So that means I'm going to divide the interest rate by 2 and I'm going to multiply the compounding periods, the years, times 2, right? So let's go look at this. So the interest rate is going to be 9% per year. And then I'm just going to divide that by 2, which is going to give me like 0.045, right? That's going to be my I value. And I'm just going to highlight that so that I have it. And I have my future value, right? My N value is going to be the number of years times 2 because it's, again, semi-annually. And she says she wants to pay off her loan early. It's due in 5 years. So let's say 5 times 2. So 5 times 2 is 10. Right? So my N value is going to be 10. Now I have all my values. I'm just going to go put it back into this equation that I made up here. PV equals FV. Again, you could always write it as A. Doesn't matter. Whatever you decide to write it as. So PV... PV, which is the present value, is equal to the future value, 1 plus I to the power of negative N. And you need to make sure you write that negative in. So the future value is going to be $10,000 on this loan. 1 plus 0.045, negative 10, right? 10,000 times 1.045. I always do the addition first and then I put everything into the calculator. So 10,000. And I know that 1.045 to the power of negative 10, and make sure your exponent's a negative, times 10,000. If I go in and write that all down, it's going to be 6,439.28. That means if she wants to pay this off right now, the creditor will be willing to accept $6,439.28 today. Therefore, creditor will accept $6,439.28 today in order to pay off her loan in the future, right? And if she has that much money, then she might as well pay it because she'll save a lot of money in interest. And that is it for present value. Again, you can go up here. The homework is listed. It's on page 439 to 441. Okay.